Alright guys, we're going to talk about transformations of a sine wave and some key features. The first thing I want to talk about is the parent function of what I have graphed up here. I have two different waves. I have sine and I have cosine. So I'm going to break this down as sine of some angle and cosine of some angle. And we're going to look at what's called the domain, the range, let's say the amplitude, how to find the amplitude, how to find the period. So let's talk about sine and cosine. The domain of sine and cosine, unless otherwise stated, is all real numbers. Unless otherwise stated, that's the key. Unless otherwise stated, it is all real numbers. My range for the parent function, the range for the parent function is going to always be between -1 and 1. For both of these. And that's what I have them graphed here is my maximum y value is 1, my minimum y value is -1. What's actually going to change that is my amplitude. So there's a way we can find the range from the equation without actually having to graph it and look at your maxes and your mins. My amplitude for my parent function is just going to be 1 for both of these. The amplitude is 1. And what that means is from the middle of the wave to the top or the middle of the wave to the bottom, that's going to have a distance of 1 unit on your parent functions. Now that's going to change as we start changing these equations. And then my period for both of these, that means how long it takes to repeat, is exactly 2 pi. So that means that wave starts to repeat itself every 2 pi or 1 full revolution, because as we've discovered, this wave does come from a circle, which is 2 pi radians in 1 revolution. So those are some basic key features. Now what's going to happen when I start moving this around using my generic notation of transformations of A, F of B, X minus C plus D? Well, we already found that A gives us our amplitude. So when it's not the parent function, we're going to do the absolute value of A. Now same rules with transformations apply. When A is negative, it is a reflection over the x-axis. So I'm going to do that real quick so you can see what it looks like graphically when I change only A. Alright, so as I make A bigger, you see that my sine wave is stretching this way. It is a vertical stretch. So in terms of transformations, that's going to work the same. It's going to be the same name. We're going to say the amplitude is actually the height from the middle of the wave to the top. But if I was describing the transformation, I'm going to say this is a vertical stretch of a factor of, which gives an amplitude of. Now, if I make it negative, you see it flips over the x-axis. So none of your transformations change on A. It's still just a stretch or a shrink or a reflection over the x-axis. My B is going to be a horizontal stretch or shrink. But this is going to be opposite of what you think. When I move B, and if you notice, as my numbers, let me get to numbers right here, as my numbers right in here, as they are between -1 and 1 and not 0, because 0 makes it a straight line. But -1 or 1, the wave is actually getting stretched out. So if you're multiplying it by a smaller number, the wave is actually getting stretched out. If the number is greater than 1, you notice this wave is coming in. It's actually a compression. So as your B gets bigger, your period is actually getting smaller. If the number is between -1 and 1, not including 0, your period is actually getting longer. So we'll put that back to 1. And then our phase shift, which is C, is going to be the exact same thing, but when you describe transformations, you describe this as a phase shift because it's a wave. We just simply move C, and you can see that C is moving as I move the wave, and it just moves the wave. Now, if you notice right here, I can make a sine wave into a cosine wave just by moving it left or right. So this is an important thing to understand. This number right here, 1.57, if I bring it back to 0, I'm actually moving it 1.57 or pi over 2 units in this direction. That's why this is a plus. which actually makes it a phase shift. So I can actually say that sine of, let's say, theta plus pi over 2 would equal cosine of theta. So you can actually write an exact same wave in terms of sine and cosine by just simply changing the phase shift. You don't have to change the A, you don't have to change the B, because your amplitude and periods are going to be the same. The phase shift is what will allow you to basically match up those two waves. Now, there's an infinite amount of ways that we can do this. So here I have a negative 1.57, meaning I move this direction, but I can always move the other direction as well. So here, you can see I mash it up, and now I'm at 4.71, which is 3 pi over 2. So this can be different numbers. We're just basically moving the maximum value of your sine value over to the maximum value of your cosine value. And this is telling me what transformation actually does it. That's my phase shift. And then last but not least is my D. And D doesn't change. That is a vertical translation up or down based upon the number. As it's moving here, it's moving up and down. All right. So that's just a quick refresher on transformations, on what they do, how it applies to a wave. Now let's talk about how can I find the range of any function. So I'm going to get rid of my graph here, and I'm going to, all right, so I got rid of my graph here, and we're going to look at this equation, -2, or this expression. Let me put an f of x in front of it. That makes it an equation. This expression, well, this equation, -2 cosine of pi times theta minus 4 plus 7. And I'm going to ask you, what is the domain and range of this? I'm going to ask you, what is the amplitude? I'm going to ask you, what is the period? So let's just take a look. Let's see, domain, unless otherwise stated, for sine and cosine, is all real numbers. That's easy enough. My range, I have to do a little manipulation on. I know that my original range, this is my original range, was from -1 to 1, but that's not the range of this function. I need to take my amplitude, multiply it by 1. So to find this, I'm going to take negative the amplitude plus my translation on both of these. So I have a negative, and then I want the positive. So 2 plus 7. So I'm basically doing -1 times 2, which is my amplitude, and then 1 times 2 plus my horizontal, my vertical, I cannot talk today, my vertical translation. This gives me a range of 5 to 9. That's easy enough. All right, my amplitude is just the absolute value of my A, which is 2, and then my period is 2 pi over the absolute value of B, which would be 2 pi over pi, which gives me a period of 2. I mean, it takes 2 units for this to repeat. So these are key features. You've already seen amplitude and period before. If I ask you for the phase shift, it's simply 4 units to the right from our transformations. This -4 means we're moving it 4 units to the right. Pretty straightforward. If I ask you for your vertical translation, it's 7 units up. And if I ask you for a reflection, this is a reflection over the x-axis. It is a vertical stretch. It is a horizontal compression, because this is greater than 1. Pi is greater than 1. So pretty straightforward transformations with key features. Not really bad. Transformations are transformations. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.